some businesses have more applications than others, right? Now, in most environments or within our environment, we have typically a lot of applications than ever before, than what we've had, in many years before. So in this video, we're going to cover all things application control. And there's a couple of key areas of what we're going to cover together. And this is all about managing the risks, the challenges, and how we both effectively manage application control within our environment. And the very first component is, well, what is application control? Now, if you haven't heard what application control is, think of this as an unauthorized application running. And this is typically us preventing unauthorized applications from running within our environment, right? It's restricting and controlling those applications and what they can do within our environment. So let's just take as an example that we have Facebook. Facebook's an application, and then within Facebook, there's a bunch of features and functions that could run. Things like there's games, there's chat, there's maybe marketplaces. Now, maybe certain users within the business actually require the gaming and the chat features. Maybe certain users may require the marketplace. Maybe we don't require any of these. So within the actual application itself, you are going to be able to control the nature of what people or what the application can then go away and reveal, right? So if we have users again that are then requiring access to that, well then yes, they can access all functions and features, or they can access very limited functions and features, right? So you can then go away and control the nature of that application. And there's a couple of tool sets or technologies that can help us with that. And there's two that I can sort of think of as we're covering this video. And the two functions, well, the first is our licensing. So there's licensing programs that allow us to basically manage the licensing of that software. And what would typically happen is there's a portal here. Let me just write portal. And then what would happen is as the licensing program goes out, it will validate and verify that the user has access to download or not download that file. And then they would be able to download and run, obviously finally run or execute that file. So with the licensing server, think of this as our way to manage the access of our components. So we go into the portal and specify who has access to what. Maybe all users have access to a certain application. So should that user go out, make a call to that portal, they'll go away, they'll validate and authenticate to that server, they'll log in, and then we can obviously specify who would have access to what. Now, that's one function. Now, the other function here in terms of the technology that's available to us is the traditional, let's write this out, allow and block functions. And this is typically done across a couple of different application stacks. So let's just talk three common technologies. So we've got our maybe endpoints. And I don't know why I'm working backwards, but this is why my brain is working right now. We've got our, what else we got? We've got our UTMs and our IPSs. And we've got our filtering services. So let's just say we've also got our an MDM. So these are typically seen across these three different sort of services. Again, if we're running a UTM, Unified Threat Management appliance in our environment, or traditional firewalls nowadays are all UTM enabled, or IPSs, we can go away, we can restrict and define what application functions can be done. If we've got MDM solutions in place, so if we're controlling our mobile device management, we can restrict basically what applications can run and what not run. And again, with the endpoints. So traditionally three different types of technologies, if you want to call it. These are all sort of ways to control the effectiveness or control the application use within our environment. So again, at a network level, maybe at a host and infrastructure level, as well as our endpoints here, which we can do it on the actual hosts themselves. And there's, again, two functions that allow us to do this. One, we can go away and enable an allow list and a block list. And allow list basically says, well, we'll have to go in there and actually configure the allowed apps. And this is obviously seen as more secure. However, it is more admin right? Because as an admin, I've got to go in there now every time there's a new application and either allow it and then create maybe a deny list away and then say, look, anything in this list is allowed, everything else by default would then be not allowed. And the same is kind of true when we talk about the block list. We'll go in and we'll create a block list and then says, well, anything outside this list is basically seen as. So with our block list, we then basically say, well, everything is allowed by default. So I'm going to say allowed, except, and then we can put an exception rule and says, well, anything except this list, then, that's going to be then blocked. So by default, everything will be allowed, and then we create an actual list that says anything inside here, well, that's not going to be allowed. Now, typically with this, well, this is seen as less secure. You can imagine why. And number 4 is, well, there's less admin, right? So we don't have to go in there. By default, everything is going to be allowed in the environment. And then we can just go away and specify the block list. So maybe we just got a category or we've got a bunch of functions within the application, and then we can just create them as the block functions. And finally, as we continue on, there's race conditioning. Now, with race conditions, these become problematic within the environment because typically what would happen is you've got a dev team that go away and they'll build an application to function a certain way. So what would then happen is as the application runs, the application would need to run in a certain manner and usually down a sequential path. And this would be just going, well, as the application runs, the application will need to go do 1, 2, 3 first, 1, 2, 3 second. What would happen is with race conditioning is basically this will allow things to happen that's kind of weird in the environment, such as writing to files. And this is obviously something like when we need to write to a file, well, the first thing that we need to do is check for the permissions and then make changes. Now, with race conditioning, it kind of happens as this sort of being the problem, right? And this will allow for those users, or it will make access to people to write access to files, which then they may not have access to certain functions, right? So for that to happen, that's seen as a risk because we don't want people writing or having the ability to write to a file because of some weird glitch within our application. So with race conditioning, what would then happen is there's obviously, if you're aware of CPU threading, the thread will go away and it will take bits of that code and then obviously take increments or take information from that session, right? So from there, what would happen is it will take instances of that process. So it will look something like this. Instead of the application running from this sort of way down from 1, 2, 3, it may run like this. It may take number 2 first, and then it'll go 2, maybe number 3, and then maybe number 1. So you can start to see that as we go through that threading process, things like this will then be able to happen. So with race conditioning, it'll allow people to do things like writing to files, which we don't want that to happen in the environment. And typically what we'd like to do from there would be, this would be things like our atomic executions. And atomic execution is, as we sort of define this, execution of the atomic component is basically saying, well, then I'm going to put a specific category in here that all these features must run in this format, right? So that will sort of alleviate any sort of race conditions that happen in the environment, which are obviously seen as a risk. Now, in this video, we've covered everything from application control in an overview session. We've discussed the what, the technology that's enabled, that technology that allows us to enable this. We've spoken about race conditioning. Now you can go away, you can look at race conditioning, some issues with this. Again, this is as an overview component where we discussed how applications are developed, CPU threading challenges, some common issues with the race threading. So should these services not run simultaneously? If they do run simultaneously, then we've got some challenges. So to circumvent those challenges, we'll talk about atomic execution. And in a nutshell, atomic execution just says that in these functions will need to run in a very specific manner, and then that's how we can circumvent any race conditionings from occurring. I hope you've enjoyed this video. As always, I will see you all in the next video.